We're going to add custom search to a Next.js app that queries a serverless database that includes aggregations with Xata. Hey team, I'm Colby Fayok. And if this is your first time here, make sure you hit subscribe and click that little notification bell for future web dev content. This video is brought to you and sponsored by Xata. Xata is a serverless database solution that focuses strongly on the developer experience part of actually building a serverless database. Not only do they make getting up and running easy with a nice CLI, but they have a powerful search client that's built right in, including a playground where you can customize your search right inside of the UI. Not to mention it's highly scalable and gives you a really powerful way to manage your data inside of your application. Well, we're about to dig right in. Make sure you head over to spacejelly.dev/Xata where you can start building for free. So actually digging in, we're going to add a custom search experience to an online store to make it easy for our visitors to find what they're looking for. We'll import some data so we have something to work with, and we'll see how we can use the dashboard not only to play around with searches, but actually be able to get our code snippets and just generally make it easier for us to integrate into our application. And pulling this all together, we're going to be building a Next.js application, which is a React framework that gives us a lot of superpowers on top of React. Particularly, we're going to use this product listing starter that I put together that's going to give an easy way to follow along with what we're working with. So to get started, I'm going to go ahead and copy this command for yarn create next app and paste it in my terminal, where I'm going to additionally append my product search, which is going to be my product name. And what this is going to do is Next.js is going to copy down my existing starter project. It's going to start to install all the dependencies, and it's also going to reset Git history, so we have a great place to start off. Once it's ready, we can now navigate into that directory and then run yarn dev, where we can see Next.js is going to spin up a local server. And when we open it up in our browser, we can see that it looks kind of similar to what we saw earlier, but this is just going to be the starting point, and it's loading all the data locally just so we have something to start with. If we start to look in the code, we'll mainly be working out of index.js today, where we can see that we're pulling in our products from this sample of 50 products, which is a CSV, which I actually have using a custom loader inside of our Next.js config, just so that it's easier to get up and running with this project. But if we start to scroll down, we can see that the rest of it is pretty much just a React application that's dumping all this information on the page for us. Now, the only thing that really is Next.js specific is get static props, where it's mapping through that data, correcting a little bit so that we have a similar experience for when we import it into Xata, but then it's also grabbing the categories and just feeding in those props for us to use in the app. But inside of our project, if we look inside of the data directory, we can see that we have two samples here where we have this 50, which means it has 50 rows of data, but then we have this other one that has 7,000 rows of data. This is what we're going to import into Xata so that we can actually see how scalable this is and how we can still grab a fast search experience by using their amazing APIs. So let's do just that, and the first thing we need is a database. So if you haven't signed up for an account yet, make sure you head over to spacejelly.dev/Xata where you can start your account for free. But once you log in, you should be able to see my workspace where you shouldn't have any databases yet unless you already have an account. I have a demo up here, which you won't see. This is just so I can have the project that I tested before actually working through this. But what we're going to first do is actually add our database. So I'm going to head over and click the add database button. And I'm going to add my name of my cool store. I'm going to select the location. I'm going to use US East 1 because that's closest to me, but you can figure out whatever one makes sense for you. And then I'm going to go ahead and click create. And just like that, we have our new database where I'm going to go ahead and click through. And now we have a blank slate to work from, where we have a lot of options for what we can do. We can even import some sample data right into Xata from the dashboard, or we can start from scratch. We can add that manually. But what we're actually going to do is import this data using the Xata CLI, which will make this much easier for us, especially because we want to add all that sample data for an online store. Now to get started with the CLI, I'm going to head over to my terminal where I'm going to run npm install -g, where -g is going to be the global flag so that we can use it anywhere inside of our local environment. And then I'm going to pass in at xata.io/CLI. And that's going to be the package that installs so that we can use the command line inside of our project. But once it's done installing, we can run xata-h, where we'll see that we're going to get the help menu, including all the commands that we can use, but more so importantly, we can see that it actually worked. So next, we want to actually log into Xata so that we can use it to access our account. So we're going to run xata auth login, where it's going to go ahead and prompt us how we want to actually be able to access it. And I'm going to go ahead and create a new API key in the browser, or optionally you can create your API key and then use it here. But to make it easier, I'm going to create a new one where it's going to now open up a page inside of the browser But then I get to tell Xata what I want to name my API keys so I know how to reference it later. So we can't use any spaces or dashes. So I'm going to say my cool store dev, which is going to just let me know that it's my project and it's my development environment. And I'm going to click create API key. And then we have congratulations. So I'm going to close this tab and then I'm going to head back to my terminal where we can see that I'm now all set and we can start using Xata. So next, let's actually import all of our data. If you remember me mentioning before, inside of our project under source data, and then we have these Amazon sample datas with the 7,000 rows, we're going to import this into our project. So in my terminal, I'm going to run Xata import CSV, where I'm going to specify that location of source data, and then I'm going to run my autocomplete so I can find that 7,000 row file. And I'm going to specify 2 additional flags. First of all, I'm going to say that I want my table to be named products. And then I'm going to also say I want to pass in the create flag. And what this is going to do is it's going to say that I want to create a new table and I'm going to call that table products. And I'm going to hit enter. Now we can select the workspace that we want to run this on. Now, as we mentioned earlier, I have a demo one, but likely you just have my workspace. So you want to select whatever workspace you're using for this, where you set up your new project. So I'm going to select my workspace, then I'm going to select my actual database of my cool store. Then finally, the branch that I want to run this on, you likely just have main if you're following through with me, but you can actually set up branch workflows. We'll get to that at another day, but let's just hit enter on main. And from this point, Xata is actually going to try to import all of our rows into our Xata account. And once we see that it's finished, we can head back into Xata and you can either refresh the page or it'll likely just refresh the table for you. But we can now see that we have 7,000 records, which is what that file had of all of our product data. And it was that easy with just that Xata import command. But now that we actually have this data, let's start to use it and let's actually pull it into our application. Now back inside of our app, we ultimately want to start to use this to make a request to Xata to pull it into our application. Usually that comes with a lot of base code that I need to write, including the client, trying to actually import the SDK and do things so that I can actually get set up. But let's actually use the CLI to make that easier. So in my terminal, I'm going to run Xata init, where similar to what we did when we imported it, we're going to be asked some questions for how we do this. Now, first, I want to select my workspace just like I did before, and then I'm going to select my database so Xata knows what to actually use, but then we have a few options for how we actually start to use this. Now, personally, I'm not on the TypeScript train quite just yet. I'm getting there, but I want to actually just use generate JavaScript code with ES modules, but you can use whatever you want at this point. So I'm going to go ahead and select that option, and then finally, it's going to ask me where I want to output this file. Now, this really depends on personal preference for how you organize your project. Personally, I like to have a lib folder, lib, inside of my source directory. So I'm going to specify source lib and then xata.js, and I'm going to hit enter. And finally, do you want to generate the TypeScript declarations? Now that probably would be fine for me to just do. Again, I'm not super into TypeScript of the world yet, but let's just hit yes and go with it. And it's going to go ahead and first add our Xata client. We can see that yarn add command, where it's going to go ahead and install the SDK for us. And then it's going to set up a bunch of extra code. So I'm going to go ahead and select my branch. I'm just going to stay on the main branch for now, rather than trying to set up another one. But then finally, it also asks me if I want to set up my .env file so that I don't have to worry about actually adding my keys, or rather it did set up the .env, but this is actually going a step further and asking me to add it to my .getignore, which is important so that you don't compromise your keys. So I'm going to again hit yes for that one. It added it to the getignore. And after those steps, we can see that now we're actually ready. Our project has been successfully configured and we're ready to get started. If we want to see what actually happened behind the scenes, we can run get status, where we're going to see all the changes that were made, including that package.json, where we added that new package so that we can work with the SDK. We can see we have that change in the getignore. We can even see that we have a Xata RC, which is going to set up our configuration, as well as our source.lib, where if we look inside, we not only have those types, but we have that Xata file where it's going to include all that client code that we don't now need to write. So now let's actually get started and make the request inside of our homepage for our data. If we head back to our Xata dashboard, we can see that we have a few options on the side here, where I'm going to select playground on the left here. where we can see by default, we're given this little code snippet that if we click run code, we can see that Xata is going to actually make a request to run this, where it's going to get that Xata client, similar to what we actually have in the code. It's going to run this command of xata.db.products.getPaginated. So it's going to get a paginated list of all of our products and console log that out, where we can now see on the right that we have that data. And this is exactly what we need, or rather, this is exactly what we're going to do inside the application. So what can we do? We don't need to just simply try to rewrite this. We can simply copy and paste this into our homepage to get that first list of products. Now, before we do that, alternatively, we can head over to our table itself, and we'll see that we have this button up here called Get Code Snippet. And if I click this, we can see that it opens up this new tab. It shows where it's adding that CLI like we already did. It's already running init, which we already did, including the database, the URL for it, so that we wouldn't have to actually specify that through the CLI. But then we can see that we have all these options for actually being able to make requests using that client, where we can see that similar code of running that get paginated, but it's passing in a particular pagination size for us this time. So actually, let's just go ahead and copy this snippet, where let's grab everything. We first want to import our Xata client. And back inside of the application, I'm going to paste in that import statement where we know that our Xata isn't in that specific location. So we're in the pages directory. So let's go up one and then back into lib. So I'm going to say, instead of just the current directory, I'm going to go up a level, and then I'm going to go into lib, where ultimately we're going to reference Xata. But then we can copy the rest of this, including const Xata and const page. We're back inside of index.js. I'm going to navigate all the way to the bottom, where inside of get static props, we're going to run those commands of grabbing the client. We're going to make the request to grab the page data. And before we start mapping this out, let's actually log out console log page, and then let's spin back up our development server. And if you haven't yet, make sure you at least restart it to get that environment variable. But once our page reloads inside of the browser, we should be able to look inside of our terminal where we have all of that paginated data listed out. And that's exactly the kind of shape that we need to inject it right inside of our application. Now, if we scroll to the top of that page data, we can see that under page, we're going to be looking for the records, where that's going to include of everything. So our products array is going to be page.records. So instead of actually setting up this entire Amazon products map, I'm going to say constant products is equal to page.records. Alternatively, we can use destructuring, where inside of this page, we can say we want to grab the records and then rename it to products, as just a little bit less code in order to produce a similar result. Now, if we head back to the browser, we will have to refresh the page so that get static props actually runs again, but we can see that we now have different products showing up here than we did when we were loading it just from that 50 sample. We can see the categories are slightly different as well, and we'll see that that'll change over time as we pull in more and more data, specifically as we grab these dynamically from Xata. So great, we're pulling in our first set of data. Now let's actually add some interactivity here, where if I want to look through all those products, that's going to be a lot, 7,000 to look through all those products. Instead, I want to be able to search those products, whether it's the categories or actually using the search, where if I search something like toy here, we can see it's actually not wired up right now. So let's get that wired up, where we're going to make a Xata request anytime somebody searches for something. Now back inside of our Xata dashboard, if we head over to the search engine tab, we can see that we actually have a search input here, where let's specify toy, kind of like what we were looking before, and we can see all the results that would come up if somebody is searching for toy. We even have a few options here that we're going to cover later inside of the tutorial, but we can see that we can get pretty advanced for how we're actually making this search. But for now, I just want to reproduce this basic search. And if we click this Get Code Snippet button, we can see that similarly, we get that installation code like we did before. But now, instead of the Get Paginated request, we can see we get that search request where it's going to run Xata.search. It's going to even pass in that query where we'll update that to do it dynamically. But we can see that we can do it to our products table, including some settings, which we'll be able to configure later. Now at this point, when we're actually working with Xata, we're going to be using that .env file, where importantly, we have our API key. Now this is something that we can't, or we don't want to use inside of the client, meaning in the browser within the actual React application. Otherwise our API key could be exposed. So what we want to do is we want to wrap that with a secure proxy by using a Next.js function. That way we can securely make that request to the search, where we're going to create a new search endpoint by doing that. Now, just as a quick note, if you were wondering, we were able to do that inside of get static props because get static props runs on the server. It's not going to be a client-side request. So this is secure in the way that we're doing it here. But inside of my source pages API directory, I'm going to create a new file. I'm going to call that search.js, where inside I'm going to paste in some boilerplate code, which you could also just copy from this hello function, which is pretty similar, where what we're doing in here is we're creating an async function handler, where we can see we get two arguments, our request and our response, where first thing we're going to do is we're going to parse the query from our body, the request body. Now that's going to come in as a string, which is why we run JSON parse, but this is going to be the search query that we're going to pass in dynamically in order to make the search. And then finally, once we have that, which we'll add in between here, we're going to pass back a successful response, and then we're going to pass back the products, including an array, which we have an empty one to start, which is going to pass back our results to whoever is requesting it. Now to actually make that Xata query, we can head back into our index.json file. We're at the top. Let's grab that get Xata client call again. I'm going to paste that in there. But again, we need to make this dynamic where instead of going up just one level, we need to go up 2 levels where we can get that lib. And just as a reference for future note, you can also set up inside a JS config to use the @lib directory, which we're not going to run through right now, but you can use that as a way to more easily reference the lib directory when you're doing this. But then heading back to Xata, I'm going to first copy that const Xata for getting the client. I'm going to paste it in above the handler function, and then I'm going to grab that request to actually grab the records and paste it in right after I destructure that query, where instead of passing in toy, I'm going to pass that query in right to that search request. Now, before we actually start using that, I'm going to paste in that search snippet inside of my playground, where I'm going to console log out these records and hit run code. This is going to give us a way to kind of see what the data is going to look like before we start using it. Where if we look through here, we have an array at that top level, which will have all of our products data, but we can see that our record is actually nested inside each of them. Now, I like to clean up my data before I pass it back inside of that request where it makes sense. So what I'm going to do is I'm going to create a map statement and go through, and for each of those items, I'm going to pass back the record instead of the top level one that includes that table name. So inside of that return statement for the JSON, instead of just passing the products, I'm going to say I'm going to pass in my records, and then I'm going to map through each of them, and I'm going to destructure the record from that first argument, which is going to be each and every one of those records, and I'm going to pass that right back into that mapping function. So ultimately, I'm going to get an array that includes each and every one of those records. Now, if we head back into index.js, I already gave us a head start for trying to actually set up this request in order to trigger based off of the search input, where we can see that first of all, we're storing that search query. We can see that I'm even using debouncing so that it's set to debounce at 250 milliseconds. That way, if somebody's typing really fast, it's not going to trigger a million different requests. It'll only trigger every so often. That way we can reduce the calls that we're actually making. But ultimately, it's doing that by using this handle on search method, which is setting that search query debounced from the current target value, which let's follow this handle on search, which is coming from that input that we saw inside of the application, where it's a type of search, its name is query, and every time that value changes, it'll trigger that function. Hence why we want to make sure we minimize it, because every time someone types a key, it's going to trigger on change. So what we're going to do is we're going to say anytime this search query changes, which will again go through that debouncing process, every time search query changes, we want to trigger a new request. So to do that, we're going to use this use effect hook that we already have imported from React, or import it if you don't have it now. Where the way I usually like to organize this is I like to set my use effects above my functions, which are before the return statement, and below any of the constants that I set. That way it's just easier to read how I'm actually using my data. So I'm going to say use effect, where I'm going to pass in that argument, and I'm going to also pass in an array, where for the array, our dependency is going to be this search query, so that anytime that changes, it's actually going to fire our use effect function. But first of all, I'm going to say at the very top here, if I don't have a search query, I'm going to simply return, because I don't want anything to happen if I don't have a query. But if I do, I'm going to run an asynchronous function. Let's just call this run, or really whatever we want. And it's going to be self-invoking. And the reason I'm going to do this is because I like to use the async await syntax, where alternatively you can just chain a then to the request, but I personally like to use this method. But I'm going to run await fetch, and I'm going to make that request to /API/search, that endpoint that we created. And I'm going to also pass in a second argument, which is going to be my options, including a method of post. I'm going to also pass in a body, where we're going to pass in JSON stringify, where I'm going to say that I want to pass in an object where the query is going to be equals to my search query. Now I'm going to also chain on a then here, but I'm just going to pass in the response and turn that response into JSON because that's ultimately what I want to work with. But that's going to return what we're returning from our endpoint, where we want to destructure those products so we have them easily able to be used. So I'm going to say at the beginning of this fetch constant destructured products, and it's going to be equal to that await statement. So now I have those products to be used. Now, in order to display these products, I need to actually store somewhere where I'm going to actually put those results. So I'm going to create a new instance of state. Let's call this constant search results. I'm going to say set search results as the setter method. I'm going to set that equal to use state. Now, first off, if I head back to my use effect, if I don't have a search query, just to clean things up in the event that this runs because I cleared out a search, I'm going to say set search results to undefined. That way it just clears out the UI. But then after I actually get my products, I'm going to say set search results, and I'm going to pass in my products so that ultimately after this request runs, I'm going to then have this search results, which is going to be all my products. So now let's actually test this out. Once I open up my application, I'm going to open up my developer tools and head over to network because I want to actually see what happens here. And then inside of this search bar, I'm going to pass in toy. And we can see that immediately after I add that, we now have this request to search. And if I look through and if I scroll over here, we can see that I now have that payload returned that includes all of that product data that is represented from that search. And we can even see that because I searched toy, the top result is going to include toy inside of the actual data. But we can see that the UI isn't updating, and that's because we haven't actually updated anything to include that. So back inside my application, I'm going to say after my search results, I'm going to say constant active products is equal to if I have a search query and it has a length and I actually have search results, I'm going to say I'm going to pass in the search results. Otherwise, I'm going to go back to my original product data, which I'm getting as that prop as the source of those active products. But now that I have active products, I'm going to scroll down into my application, into the actual React code, where we can see that once we're actually mapping through our products all the way down here, styles.products, I'm going to change that products mapping statement to my active products. Now, if we head back to the application, I'm going to get rid of the developer console at this point. We can see that if you didn't refresh yet, our UI actually updated. That's because we're still storing that state and we were able to update what we're actually passing to the UI. But let's refresh the page just so that we can see what this is actually doing. And it looks like I did have a quick error here, and it's because I wasn't checking if that search query even exists before grabbing the length. So to fix this, I can head back to active products. I'm going to add optional chaining, which if you haven't heard of optional chaining, you can check out my video with the link above. But this is going to allow me to say, check if search query actually exists, and then only then get the length. But now that everything's good again, let's actually try a new search such as skateboard, where as soon as it starts to load, we can now see that we're getting those skateboards show up in the UI. So this is great. We got it to a point where not only are we listing products, we're actually able to search for products. But let's take this a step further. I want to be able to use these categories on the left to not only dynamically show all the categories I have, but then to be able to select these categories to actually improve the results for my search. Now let's head back to the Xata playground where we're going to actually start building this query, where I'm going to create a new constant of categories. And I'm going to set that equal to where I'm going to await the Xata client. I'm going to say I want to access the database of products, and we can see the autocomplete there. And I'm going to run the aggregate function, where I'm going to pass in an argument of an object, where the first thing we want to do is we want to define the name of the aggregation. So let's call that categories. Then I'm going to set that equal to a new object, where inside we want to specify the key of what aggregation we want. And I want top values, so I'm going to specify that. And then finally, I got to configure the column that I want the top values of. So I'm going to say column of category. I couldn't spell it right, but luckily autocomplete helped me out there. But we can see that, let me spell categories there right as well. But we're creating a new constant where we're grabbing the product aggregation, where we're creating a new aggregation of categories that grabs the top values of the column category. Now, finally, let's log out the categories so we can see that this is actually working and run the code. And just like that, we can now see that we have our aggregations for categories that include all those different categories. We can see toys and games. We even have some data that doesn't include a category apparently, but also we have home and kitchen, we have clothing, shoe, jewelry, everything that includes, we have all the different categories for all of our different products. So to use this, we're going to actually create a new API endpoint that grabs us all the categories. So back inside my code, let's actually just duplicate that search endpoint and let's call it categories. Where inside we can start getting rid of some of the existing stuff. Like we're not going to actually need to grab a query because we're just going to grab all of the categories that we want, but we're going to ultimately pass back our categories. But now inside the playground, I'm going to grab that category snippet and paste it right at the top of that handler function, where instead of just the categories, I'm going to actually destructure the ags, which we saw in that data structure earlier. And if we look back at the shape of that data, we can see that we can probably clean this up to make it a little bit easier to read when we're returning it as a response. So we're going to take the categories values and we're going to map through that to clean up that data. So I'm going to say constant categories is equal to ags.categories.values, where I'm going to run a map statement where for each category, I'm going to return a new object that includes the name and the count of the category, where the name is going to be category.key and my count is going to be category.$count. Then we can take that categories and pass that back as is, which we're already doing. So now we have our categories endpoint. Because we're not actually trying to parse any data from a body, we can actually use this to make a request in our browser to see all the data and see that it is working. So let's use this now in the app. So similar to my search results, I now want to store my search categories. So for my search results, I'm going to duplicate that. I'm going to say my categories. And similar to what we did with the use effect, I'm going to run another use effect, but this time we're not going to actually depend on anything because we just want to get our data and set it. So I'm going to run use effect. And inside of that is where we're going to run that. I'm going to add an empty array of dependencies so it only runs once. And I'm going to wrap that async function of run so that I can run that as is immediately. And then let's say I want to await my fetch request of /API/categories, where this request is much simpler. So I don't need to pass in an argument. I'm just going to transform that response to JSON to make it easy to read. I can even destructure the categories, kind of similar to what I did with the products from that await request. And I'm going to say set search categories to that categories value. Now at this point, our data, once the app runs, should be available in search categories. But one caveat here, if we remember earlier, we had a category that didn't have a name, and we don't want to just show a category. Now from here, our data should be available in the search categories constant. But if we remember earlier, we actually had a category that didn't have a name. That's because some of the products are missing a category, but we don't want to show an empty category in the UI. So let's filter that. I'm going to create a new constant of active categories. I'm going to set that equal to search categories. And similarly, we're going to check that that exists first, where I'm going to run a filter statement and say that I want to look for the name destructured from that categories array. And I'm just going to check if that name exists. Now, in instances where search categories isn't yet available, we want to make sure that active categories is still an array. So at the very end, I'm going to chain on an OR statement where I'm going to pass back an empty array if it's not available. So what this is saying is it's going to look and see if search categories is available. If it's not, it's going to pass in that empty array. Otherwise, it's going to filter out anything that doesn't have a name. And like before, let's actually now update that inside of the UI. So I'm going to grab active categories and head down to where I'm running that map statement. I'm going to replace categories with active categories. And this time we actually have to update the UI a little bit, where before we just had an array of strings, where now we have an array of objects, including the key and the count. So we can see here we're passing category. First, we got to say category.name. And for our key, we want to do the same thing, category.name. For our input, we want to make sure we're passing a value of category.name. But then finally, we can also add the count. So I'm going to say in little parentheses at the end there, I'm going to say category, where I need to also make that a variable. I'm going to say category.count. And now if we head to the browser, not only can we see that all of our categories loaded in, we can now see the count of all those categories, where we have a whole lot of toys and games in there. We also have home and kitchen. We have all these other things. They're ordered by the number of items in that category, and we can see that we can select whatever we want. Now, if we try to select something, it's still not going to work, but now we can actually wire that up to make that request. Now, heading back again into our playground, I'm now running that Xata search that I pasted back inside of here, where I'm making that query of toy and we can see our data. But what we want to do is we want to filter down this search to also include that category. Now to do that, I'm going to open up this object so that what I'm going to do is on the table object here, I'm going to add a new filter, where if I start to write this, I can now add the filter that I want, where I can add my column name of category, and let's add something like toys, ampersand, which is and games, and let's try to run this query. Where now what we're seeing here is we're running that search query of toy, but we're also saying that it needs to be in the toys and game category. Now nothing in any of the other categories is going to actually show up here. Where similarly, we can change this to something like baby products, where if we now run that code, we can now see that we only get products where we're still matching toy, but that are baby products. So first off, back inside of my search endpoint, I'm going to first destructure my category from my JSON body. But then I want to dynamically add that category as a filter because I don't want to add an empty filter, as that'll actually change how that query is made. So we need to dynamically create this object before we pass it in. So I'm going to create a new constant of table. I'm going to set that equal to an object where my table is going to be equal to products. But I'm also going to say that if we have a category, I'm going to set table.filter is equal to an object where we're going to add that category filter and pass that right in using that value. But at this point, I can now pass in that table instead of the object into that array, where now the only thing left to do is actually pass in that data from the app. So back inside of our index.js, we're going to head back to that original use effect where we're making that search request. And instead of saying that we only want to look for that search query, we're now going to also look for that search category to trigger changes. And we're going to say if we don't have a search query and we don't have a search category, we want to set the search results to undefined, meaning we don't have a query, we don't have a filter, so nothing's happening, and we don't want to use filtered results. But now I can take that search category and I'm going to pass it in as a category value into the body. But now all that's left to do is if we scroll back up to active products, we can see that we were looking for this search query to exist. Now, because we're now looking for both a search query or a search category, this is a little bit too strict. So I'm going to go ahead and get rid of that. And what I'm going to actually do is format this so that I'm going to say that if our search queries exist or search results exist, we're just going to use that. Otherwise, or that or statement, we're just going to use the products. But now let's load up our application, and now let's try to select a category such as toys and games, and we can see we made that search request and we can now see all of the toys that we have in that category. Further, we can actually start to search on this now, where what if I only want Batman products, where I'm going to search for Batman, and once that query actually loads up, we can see that I'm getting all those search results for toys and games where something matches Batman. Now, maybe I'm not just looking for a Batman toy, maybe I'm looking for something for my home with Batman in it. So I'm going to select home and kitchen instead, where we can see once that loads, I can get some nice things for my home. Like maybe I want some super soft bedding, but either way, what's happening now is we saw that it dynamically switched which category we're filtering on because we're now passing that into that endpoint and ultimately that search result or search request to Xata. The nice thing about this is this gives us a really flexible way for people to be able to find the things that they want and care about, not just a whole list of products that they might get a little bit of granularity on if they get the exact search request or just only the categories, which can be pretty broad. Now finally, this is already powerful in itself, but we can take this yet to another level by refining how we're actually making those searches. If I head back to my search engine, let's first make a query of toys, where once we can see that loads, we can see all the different results that we have. Now, the main thing we want to see here is this is searching both category and product names, where maybe we only want to search some data. Now, if we start to look at this target option here, we can see that this lists all the different columns that we have. And if we first deselect all, we can see that we're not actually going to make a query to any of the columns, but let's start adding things individually, such as what if we only want to query the product name? Where if I now select that, we can see that we're only getting the results for the product name. Now, similarly, if I deselect that and only select category, we can see that we're now only making those searches for the category. But what this ultimately does is it allows us to narrow what data points we're actually being able to search. So for our instance, it probably makes sense that we do have a product name and a category searching, but we don't want something like product URL, where we still might get toys inside of that URL, but that might not make sense for what we want to search. So let's include product name and category in our search. Now again, let's take this to another level where we also have this boost option here where we can add a booster, and what this is going to do is it's going to say that we want specific reasons why something might be more powerful to our search or more valuable to our search than other things. For instance, if we select this column booster, we can see that not only can we select the column that we want to boost, we can see how much we want to boost it by. So for instance, if I select product.name and let's say I set that to 4, We'll notice that our results didn't actually change, but if you notice on the right here, our confidence did. Now let me get rid of that again. Watch these numbers. We have 6159, we have 4459. Let's get rid of that booster now. We can see that dropped all the way to 15.4 and 11.15. Now let's add that back. If we now add back our product name and set that again to 4, we can see that it's now really confident that this match is going to be correct for what we're trying to search on. And we can look through the data and see that confidence of all of the searches that we're actually making. Now let's try changing that to something like category, where we can see that as soon as we change that, we actually get slightly different results. Now, if you didn't see that, let me again switch back to product name, where we get our original results. But now let's select category again, where we get those slightly different results, even if it's some of the same things, which is a slightly different order, but it's because now it's putting different value on the category as opposed to the product name. So it might see things like in this particular example, Toy Smith, that's not just the word toys. So because we were before doing the product name, but now we're doing the category, it's going to see those matches as different values. But ultimately, unless we're actually doing a category search, which would make sense here, we probably want to boost the product name, as that's probably where we want to put our most value when we're making a broad search like this. Now these results are already pretty good, but let's just do one more thing, where if we go up to settings, we see this option of fuzziness, which is basically typo tolerance. Now if I head back to my search and I change this from toys to tozy, which is basically toys misspelled, we can see that I don't get results, but that's because I don't have that in any of my results. But let's go back up to settings and let's set the fuzziness to 1, where it's saying that I'm going to give it a tolerance of 1 character. We can see that I now get those records or the results for the products where it does say toys, because it's able to see using that fuzziness that I was trying to say toys, and it's going to help me out where I misspelled it, but it's still going to give me accurate results. Now you can play around with that for what you feel makes the most sense for your application, but I'm going to keep mine to 1, because if we go to 2, for instance, we can see that we start to get different results on that, such as story, which maybe that you want to have that match it. But for me, that's going to be a little bit too much, so I'm going to leave it at 1 for now. But now at this point, I'm really happy with my search logic, so now I want to implement it. Now, as usual, we have this get code snippet button, so I'm going to click it. And once we see our data, we can see exactly what it's doing here, where it has my table of products, and it's going to now add this target to it. So what I'm going to do is I'm just going to copy that entire target value, since we already have most of this inside of our project. And on my table object, I'm going to paste in that target, where the only other thing that we have is that fuzziness of 1 that we can scroll down and manually update ourselves. But now if I head back to my application and I make that typo, we can see that I'm going to get those toys results just like I did inside of the Xata search engine. And I can even filter those results, such as home and kitchen, where my search typo is still going to pull up my toys results inside of home and kitchen. We can see that with just a little bit of effort, we were able to put together a really high power search engine, both by using a high amount of products, 7,000 products that we imported, as well as being able to have really articulate needs for how we actually make searches on that data set. Xata gives us a lot of power for how we actually make search requests to our data sets, whether it's small or big like the one we worked here today, or even bigger. The best part about it is the DX, or developer experience, where not only do we get that CLI, which makes it easy to import or do whatever we want from the CLI, we have that nice dashboard with all those tools to make it easy to refine exactly what we need and get the code snippets and get out into our application and be productive. E-commerce is a really great example for using search to query a large amount of data, but what's your favorite use case? Let me know in the comments. If you want to take your online store to the next level, where you start to think about performance, such as optimizing images, check out my video, Optimize Images with Responsive Sizing and even AI cropping in Next.js with Nextcloudinary. Or if you want to learn how to work with local storage so that you can save state and have the browser refresh and keep it, like maybe if you're building a local cart, check out my video, Save State to Local Storage and Persist on Refresh with React.js. Thanks so much to Xata for sponsoring this video, and if you like this video, make sure you hit thumbs up, subscribe, and click that little notification bell for future web dev content. Thanks for watching.